Um, without further delay, let me introduce myself. As James pointed out, I'm product consultant for the civil products in Bentley. So yeah, I cover our products ranging from road, rail, and some geotechnical information system. So in today's presentation, I would like to talk about what Bentley has to offer as a digital solution for rail infrastructure projects. So as you're probably aware, in the past 30 years, we were in the CAD era. So the CAD era is basically doing all your drawings and design in a 2D form. So that is the CAD era. And about 20 years back, we moved into the BIM era, which is the building information modeling era, where you can work things in 3D as well as store some information within the model. And yeah, in recent times, Bentley has moved on again to the new era, which is the digital twin era. So you may ask, what is this digital twin? So for Bentley, all our software is ready for this digital twin users. So basically, you can think of the model as a living model where you can, as the asset operates, be it a road, rail, or building or bridge, you can bring in data and add in to the infrastructure as the infrastructure operates. So in this way, it allows the infrastructure to be assessed, and you can plan financially on how to manage the infrastructure as it goes. Okay. So in terms of our offering, we have a solution for almost all the infrastructure in the world. So for today, we'll be focusing more on the rail infrastructure, and we have multiple products involved. Don't worry about the number of products, because you may need only one of it just to do the type of project that you're covering. Okay. So in Bentley, we advocate the use of workflow. So workflow means that the data from one software can be shared and interchangeable with other software. So for a rail infrastructure project, usually the what they call it, backbone of the project is using design and data from the OpenRail designer. So this solution is very robust because you can bring in all your point cloud survey data as well as reality modeling, which I'll show you in a while. And all this data, you after process, you can reuse it in the next stage. For conceptual design, we have OpenRail Computational. This is where you do your initial planning and quick costing and assess the feasibility of design scheme. And then once that is been finalized, you bring it into OpenRail Designer for the detailed design of your rail track infrastructure. And then you can also bring in geotechnical data and overlay within your rail design using GIN. All right. And then in a rail project, it's very likely you encounter bridges as well. So we have OpenBridge modeler to do the 3D design of it, and it's up to a very high level of detail. And also you can do your rebar modeling using ProStructure. You can do a steel detailing from here as well. And then when it comes to a tunnel, we have an open building designer, which helps you to model a building, taking on the data from OpenRail Designer. This is very useful because for rail track, you have something we call as the CAN. And all these values will be picked up by Open Building as you design your tunnel. And then for the structural and geotechnical part, you have Plexis to do all your slope and embankment analysis. And then the 3D model you build from OpenBridge modeler can be sent directly into RMBridge, and this process is interoperable, and then you run your structural analysis from there. And then, of course, you have probably some retaining walls along the railway network, and you can just use Step Pro and just use the 3D data from whichever 3D modeling software we have to run your structural analysis. So how is this possible? For Bentley, we, as you saw in the diagram earlier, we cover almost all the infrastructure classes in the world, be it power, utilities, rail, road. You can actually bring everything together if you wish. Yeah, and how is this possible is because we have what we call as a common modeling environment. So all our 3D modeling is done in the DGN file format. So in this way, you'll be able to integrate with one discipline to another, as well as eventually, if you decide that you want to do asset management, you can bring it into our project-wise and asset-wise platform to do all the digital twin component of your infrastructure. Okay. So in the past, Bentley has learned the lesson. We have various file format which is not compatible with each other. And this leads to things working in silo. And yeah, we find that this is not efficient for engineers. So what we do is we introduce the what we call as open civil designer. So you can have road, rail, site, whatever it is. And all this works in DGN format. And this allows everything to be connected to each other, and you can inter-reference in one software to another. Okay, so this the output from it is you can send the data to all the stakeholders, and then you can produce all your reports, quantities, and drawings from there. So this is pretty much what is in the world requires today. All right. Another feature of Bentley, why you can integrate with each other is because doesn't matter if it's a rail, a bridge, road, or building. Everything is geo-coordinated as you design. So this would mean that everything can be referenced to each other precisely, and this is very useful during construction. Okay, I'll bring you to the first product in the workflow first. The name is context capture. So basically, what you do is you use a drone to, sorry, you use a drone and capture the terrain in the surrounding. And then you download the data into context capture, process it, do some editing on some undesired component. And then, yeah, this is the 3D terrain mesh which you produce out of it. Okay, then you can even share the data on a web basis, on a view-only basis with all the stakeholders. And then all this data can be bring into our civil modeling software like OpenRail or OpenRoads. Okay, you may ask for a rail project, how is it done? So basically, this is an example of a reality modeling plus point cloud capture, which you see is very, very detailed. Okay, I'll bring you to the next software, which is the OpenRail Conceptation Designer and Overhead Line. So as I said before, the OpenRail Designer is the backbone of all the rail infrastructure projects. So just to give you an overview, this is the hierarchy of our civil product. So at the top of it is OpenRail Overhead Line, followed by OpenRail Designer, OpenRoads Designer, and OpenSite Designer. So as you can see from the diagram, this means that the OpenRail Overhead Line has all the ability of itself, which is to do the overhead line design, plus whatever can be done in OpenRail Designer, OpenRoads Designer, and OpenSite Designer. So which means that if you say you own OpenRail overhead line, you can do basically road design as well as site design as well, because all the capability has been built into the software. So the first product I would like to talk about is OpenRail Conceptation. So basically, this software just allow you to design your design alternative very quickly. You can see from the video right now, it's almost like a game-like. You just click on the surface where you want to put the things. Yeah, this showing an overlay of a station in the design. And then you can do the adjustment very quickly, as well as putting some simple infrastructure like retaining walls and such around. And also you can access between different options like embankment and bridges. And if your project has electrification, we have all the catenary masses as well. And also you can check your bridge clearance from existing road infrastructure. And then we have also the turnout libraries within, which is automated. And yeah, so from there, you'll be able to generate the costing quickly based on the bigger categories. And then this can be exported into Excel spreadsheet also if you wish to. And at the end of it, you'll be able to build all the video flybys and such, and then you can use it for clients' presentation. Okay, I'll move on into OpenRail Designer. So this for the detailed design on the track mainly, as well as some of the catenary masses. So within OpenRail, you can do your stormwater design with Stormcat. The card is just for you to bring in your point cloud data, which is very important. Say if you have a brownfield project where you need to find out where is the current alignment. Later on, I'll show you we have a regression tool which be able to use mathematical formula to find out where is the correct center line for the existing rail tracks. You have the ability also to model subsurface utility using our utility engineering tool. And then, of course, we have the overhead line to put in your masses using the library we have. And then Gain Silver 2 is just to overlay the lithology data into your rail design. All right. So OpenRail Designer, as you saw from the earlier hierarchy, integrates everything from OpenRoads as well as OpenSite. And then this is actually a legacy product from our rail track software, and as well as rail overhead line, which is both of it is already an established product back in the past 20 years. So the reason why we came up with OpenRail Designer is because we want to move into the digital twin era, where all the models can grow as the asset operates. So the previous software of rail track and overhead line are not able to be developed in such a way. So that's why we came up with OpenRail Designer. So it does what a rail track designer do, which is design the track geometry, inputting the spiral in circular curve in all the what do you call that, all the curves, and then you can do regression analysis for the best fit in existing rail tracks. So the modeling of the tracks has a detailed template library already ready. You can, of course, do your custom one. And then most important of all, we have an automated turnout ability. So that means you just pull out the turnout definition from the library, and then you can start to design it to your main alignments. And then we have the yard design and rule geometry as well. And we can do the detailed design of the overhead line electrical systems. All right. So for the geometry definition, you can put in circular and vertical arcs. You can put in multiple spiral transition definitions, including the common one like clotoid, bloss, biquadrate, parabola, and also we have the Japanese sign, which is something I hear from some users in Indonesia they require. And also you can do your rail alignment calculation and report from here. Okay, so the turnout we have almost all the common types which is used in the rail design industry: single, double, single slip, double slip, diamond crossing. These are common one. So our library also accommodates all the major rail design standard: Arima, German, UK, France, Russian, etc. And if you have your own design standard, you can definitely customize your own. Okay, so this is just to show you the interface. And also, I would like to point out that once you set the alignment properties, the geometry in the model will auto heal by itself according to the properties you put in. Okay, so this is a demo of the software. So you can bring in your data from your survey. And then this is a Brownfield project where you do your regression analysis. This is usually based on either survey data or point cloud. For the regression tool, you can do for both horizontal as well as vertical geometries. And yeah, once you are happy with your main alignment, you can design the turnout using our automated turnout tools. Yep, this is basically to do like a station kind of environment where you have a turnout. Then you can see the table of your alignment, and then you can change all the radius value from there. And yeah, finally, you can do your 3D modeling using the templates or your own template. And all this is being done live, so everything is updated as you make changes. And then finally, this is the drawing production. You can see it can be done very, very quickly. Okay, these are all the drawings you can produce. Of course, you can customize the drawings to your organization's style if you want to. And changes you make from the drawing sheet actually is back updated into the 3D model itself. So you don't have to go and search whichever change the things you want to change at. And yeah, this saves you a lot of time and trouble. Okay. Next one is also showing some of the capabilities of OpenBridge. So this one is more on the modeling side. And this is the drive-through from the track you have just modeled. The function of it is to see any obstruction of the signal, which is yeah, very important for rail design. Okay. So as I pointed out earlier, OpenRail Designer also have the overhead line electrification modeling capability, but this one is more to the catenary masses. So later on, you'll see in our next product, the overhead line designer, there is more capability to that to model all your the wires for the electrification systems. So we can have integration of the lithology data into your rail model design. And yeah, this is something you can produce yeah, at the end of it for presentation purposes. So the video creation capability is also comes with this OpenRail software. So you don't have to buy another software to do it. It's already inbuilt inside. Just to note, the station is not actually designed within OpenRail Designer, but rather using our Open Building Station Designer. So this is just being referenced into the OpenRail model, and then you do your video fly through, which yeah, what you have just seen. Okay, I'll move on to the next product we have in the workflow. It's called OpenRail Overhead Line Designer. So as you saw earlier in the hierarchy, this is what I will call as the mother of all Bentley civil design product. In fact, in the market, this we don't have anyone similar to us. So basically, if you own this software, you can basically design any civil projects, either road, rail, site, or whatever. So why we created this product is because we saw the problem in the rail catenary system design, which is very labor intensive. And then it is very manual. So we attempt to automate it with this overhead line designer. And then as you know, this electrification design is normally in the single line or 2D drawings. And then whenever you have changes, it's very hard to make because the people on the site expect to see things visually, which can help them to make the changes very quickly. So that's why this product is born. Bentley created this. So it is in order to fulfill the BIM requirement, standardize all the design, automate the design as well as giving consistent deliverables. So this product is the highest hierarchy in our civil offering. So it has all the capability of OpenRail Designer, which you saw earlier. And on top of that, you have the ability to integrate with the Siemens Cycat Master, which we understand is one of the top design product for the electrification system. So you can just bring in the data into OpenRail Designer. And then we have some tools also to analyze all the catenary masters and wire systems. Okay, so first BIM. This is very similar to what you see in OpenRail. So basically, it's just telling that yeah, you can do your track design from there, and then modify your geometry as you see fit. Yeah, basically, say if you have done your design in OpenRail Designer, when you open in overhead line, it can do the same modification, yeah, without any fault, because this ultimately is the highest hierarchy of all our civil software. And the second aim is to standardize the design. So we have the workflow where you standardize all the material constants, the contact wire parameters, messenger wires, and all the environmental condition and such. So all this is the ability of the overhead line designer to put in the parameters so that as you design things within the model, everything will yeah, follow suit. And then we have the ability to customize all your layout. So this is the feature of the engine behind Bentley software, the DGN. So something we call as a feature definition. So what we do is we allow the user to set all these standard beforehand, even from project to project. And then this file acts like a control for all the standards, annotation, drawings, drawing blocks, and such. And you can see we are trying to automate the design for the overhead line wire system. So you can create layout plans as you wish, and then you can save them as block as well. So there are typical sections like the station area, which you can just save it as a block and copy paste as you go. And then this just to show you how things can works within overhead line designer. Yeah, you can see the changes is yeah, done quickly. So yeah, one very important feature of the overhead line is the ability to analyze the sway of your wire as a result of the environmental changes like wind as well as the temperature change. And then in the overhead line design, we have what we call as a pantograph range. So this is where the connecting mass above the train connects with the wire system. So the wire sway and all the changes must fall within the pantograph range, which is you see in the diagram, the green line here. Okay, so this just to yeah, show you a demo how does it appear within your real catenary system design. You can see the pantograph range is visible as you zoom in, and then yeah, you can make sure like over here there's a mistake, and yeah, you can make some design changes to ensure it the wire fall within the pantograph range. Yep, like this one is okay. Yep. Over this section, there's a need for modification. And yeah, basically that's how things work. Okay. So another feature of this soft overhead line designer as well is you can do your multi-track design at the same time. So you don't have to do all the separate track alignments with the 3D modeling separately. So you can see in this yeah, this demo how we do the modeling concurrently. You can select a different type of catenary masses, cantilever as well as portal. You can see that on the left side, when you change things on the 2D plan, the 3D side will just update automatically. You can see that you can put in the portal as well. So you can see the components will adjust to fit with the your track alignment. So you don't have to adjust yourself, which is may not be accurate. Okay, that's about it. And also for the automation function, whenever you have reference some objects as an obstruction in the design area, all the masses will adjust accordingly to avoid all this obstruction. And then this software also help you to optimize your design by going the span of the catenary from mass to the maximum, as you can see in the next yeah, demo here. Yep, you can see the mass is being pulled. I'll show it again. You can see it's shorter now. And then when you optimize, the mass become yeah, goes on a longer span. And on, if you see on the left hand side here, it tries to maximize the cable's sway to fall within the pantograph range. Also, when in the real catenary system, you have telemetry wires. which can be analyzed in the same way as well. And then you can show all the trackside equipment like jumper insulators and such into the diagram. So you can show all the tensioning devices and model them as well. Yep, that's how it goes. And then at the end, you need some deliverable like drawings and such. So as I pointed out earlier, you can standardize all the annotation using your what we call as a seed file to suit the design requirement of you and your client. And then you can create all the cross-section drawings as well, because probably every section, the masses is different. So you need to produce a drawing so that people on the site can build it. Okay, so this is just to show the drawing production. Yeah, because you can produce drawings and all the component and the location, the bill of material as well. And then at the end, I can produce the similar visualization like what you saw in OpenRail earlier. So yeah, basically that is the feature of the OpenRail overhead line designer. So next, I would like to touch on a bit on OpenBridge designer, because in the real project, you may encounter a lot of crossing which you need a bridge. So as I pointed out earlier, it is an integrated workflow together with the rail infrastructure design, because OpenRail designer, the 3D model is also DGM based. So that will form what we call as a 3D physical modeling in the OpenBridge designer interface. So once it's done, you run your analysis using either RMBridge or LibBridge. And then, this is showing you the analysis part. And then you can produce all the reports for your design, and as well as drawing. And then you can produce the detailing as well, all within the same software. So there is a pro structure component built in, and then you can send the model for the 4D simulation. So this is the workflow of OpenBridge Designer. So it brings you from model to analysis to drawings and interoperable with other products. So of course, in the design, you start off with the 3D modeling. So that is handled by OpenBridge Modeler. And the good thing about OpenBridge is it can take in your CAN value and also your vertical elevation value, and then model the bridge accordingly. So the bridge which you model in OpenBridge Modeler already has taken care of all the CAN value changes as a bridge, from chainage to chainage. And once that's done, you send over to the analytical software. It's either Lib or RMBridge, whichever you wish to choose. And any changes you encounter during the structural analysis, it is fed back into OpenBridge Modeler, and the changes can be updated automatically. And then if you want to integrate all your geotechnical data in, you can bring in Kin. Luminati, just like what you saw in OpenRail, is more for the video flyby creation. And then if you have a special type of bridge with special shape, you can use the generative component to do it. So one example here is like the Sheikh Zayed Bridge in Abu Dhabi. You can see this is not a typical bridge design, so it can be handled with RM bridge. And then you have the wizard to help you to do the bridges quickly on the typical types. So it has the interoperability with Pro Structure. And then you can see all the tendons and the anchors, as well as reinforcement, all can be modeled within the 3D interface. And then your bridge substructure can be imported into practice as well. And then you can put in all your geotechnical parameters and start your analysis with the bridge in there. All right. The next product I want to talk about is our Open Building Station Designer, which is quite integral for rail infrastructure project. So this is an example of the model you can create. Within Open Rail Station Designer, you have the generative component as well to do your computational design. So that's why all the very unique shape can be done using this software. So the capability with Open Building Station Designer is you can do pedestrian simulation working together with the Legion software, and as well as all the other things you expect for a station. So this pedestrian simulation basically is using the station model and then optimize it and then send it over to Legion for the pedestrian analysis. And then for the BIM function, you can define all the functional space layout. So we have a catalog of all this already for you to apply. And also we have all the station related library on the components, like all the turnstiles, ticketing station, the security features as well. Yeah, all this is ready. You can even create your own component and insert it into the library. And one of the powerful feature of this software is it has a computational design element, which is what we call as a generative component. So it helps you to basically pull in the data from your rail alignment, especially when the rail alignment has the CAN value, which is important as it affects the infrastructure surrounding it. Okay, this is a workflow using a generative component on how it can work. You can see the red line there is alignment, and all the things you saw at the bottom is all the dependables to the alignment. And whenever you have changes, as you see earlier, to the alignment, you don't have to remodel the whole tunnel with all the mechanical and electrical component again. So you just have to rerun the script inside the generative component because all the dependencies already set in. So all this will help you to update the model, 3D model automatically in accordance to the change of your alignment. Yeah, you can see the new alignment is out of the older tunnel. So you can see everything out of place, and what you need to do is just update the script, and yeah, you see the results in a while. Yeah, everything back to normal again, following the new alignment. Okay. So yeah, you saw a lot of features done using OpenRail, OpenBridge, as well as Open Building Station Designer. So you may ask, has it been done in real life before? And the answer is yes, and there's quite a big number of users in the world. And one example of it is the project, high-speed rail project from Beijing to Zhangjiakou in China. So this is one example of a project which use mostly Bentley solution, including OpenRail, OpenBridge, as well as Open Building Station Designer. And they have won an award back in 2018 in the Year in Infrastructure event. Okay, so let's have a look. So it's actually to cater the Beijing 2022 Winter Olympics. So yeah, so because this new venue is very secluded, so they need to build a high-speed rail in order to connect all the event venues of this Beijing Winter Olympics. Okay, so yeah, it's already in operation actually. And next, I would like to show you a video which they made themselves for the Year of Infrastructure Award event. And then they'll showcase to you what they have done using Bentley software for the project.
In order to serve the intelligent Beijing to Zhangjiakou Railway, we organized the backbone to carry out the construction of the cooperative design management platform and had achieved breakthroughs permitted and open to traffic.
Okay, so that's an example of the project that's been done by CIC, and yeah, that actually is a digital twin project, but they refer the process of design as a BIM actually. Okay, so next I would like to show you another project done in UK, the Crossrail this MRT line. So they done using Bentley solution as well. So why they want to do it is because they want to keep track of the timeline as well as the cost of the project. And then eventually they want to operate it using the digital twin model. And then also they want to keep track of any changes and all the inspection done during the construction of the project. So you can see here on the left hand side is the actual tunnel being constructed. On the right side is the digital model. So they why they do this is because they anticipate the operation of the tunnel, which they expect to be 100 years for the infrastructure to last. And they want all the data collected during construction as well as operation to be integrated together with the 3D model. So that's why they have this 3D digital twin to help them with the process. So the advantage of it is you have visibility of where things is happening, and then you can collect the data which will help you to assess the costing of your operation. So in this way, you can plan your finances way ahead rather than just reacting to the breakdown of the structures for this Crossrail. Okay, that's about it for my presentation. So yeah, Mike, is there any question coming from the floor?